We shall now move on to the next chapter, the D and F block elements. In the periodic table, we have 4 block of elements known as S, P, D and F block elements. Group 1 elements together with group 2 elements are known as the S block elements, whereas elements belonging to group 13 to 18 are collectively known as P block elements. Group 3 to group 12 elements are known as D block elements. So the D block elements are placed between the S block and the P block elements. We have 2 series of F block elements known as lanthanoids and actinoids. So let us now study in detail about D block elements. Group 3 to group 12 elements are known as D block elements. It is because the d orbitals gets progressively filled with electrons. There are 4 series of d block elements known as 3d, 4d, 5d and 6d series. The filling of the 3d orbital takes place in 3d series, whereas in 4d it is the filling of 4d which takes place, whereas in 5d series filling of the 5d orbitals takes place, and in 6d series the filling of the 6d orbitals will be taking place. So we have 4 series of d block elements. The 3d series is known as the first series. It starts with scandium and ends in zinc. In 4d series, the starting element is yttrium and the last element is cadmium. 5d series, we have lanthanum, hafnium to mercury. 6d series, actinium, rutherfordium to copernicium. Now, which are the first series elements? The first series elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. The atomic number of scandium is 21, that of zinc is 30. Now let us have a look into the electronic configuration of few of the transition elements. Scandium atomic number 21. So the electronic configuration can be written as argon configuration 4s2 3d1. Titanium atomic number 22. The electronic configuration is argon configuration 4s2 3d2. Vanadium atomic number 23. So argon 4s2 3d3. Chromium atomic number 24. The electronic configuration is written as argon 3d5 4s1 instead of argon 3d4 4s2. 3d5 4s1 configuration will give extra stability because we know that the d5 configuration is half filled and more stable. Now consider manganese atomic number 25. The electronic configuration can be written as argon 3d5 4s2. Iron, argon configuration 4s2 3d6, whereas cobalt it is 3d7, nickel 3d8. Copper configuration is written as argon 3d10 4s1 instead of argon 3d9 4s2, because when it is 3d10 configuration it will be completely filled, d orbitals will be completely filled and will be more stable. Now consider zinc atomic number 30. The configuration can be written as argon 3d10 4s2. Thus we find that in the case of zinc it has completely filled d orbitals. It is 3d10 configuration, so it has completely filled d orbitals. So this is the reason why zinc, cadmium and mercury are not considered as transition elements, because they have completely filled d orbitals. They have d10 configuration. Next we shall discuss about F block elements. F block elements are also known as inner transition elements. We know that D block elements are known as transition elements. F block elements are known as inner transition elements. There are 2 series of F block elements known as the 4F series and the 5F series. 4F series because filling of the 4F orbitals takes place, and 5F because filling of the 5F orbitals will be taking place. 4F series are known as the lanthanoids and 5F series are known as actinoids. Next we shall move on to transition elements. physical properties. Transition elements exhibit metallic properties. Transition elements exhibit the properties of metals like malleability, ductility, conductivity. So they are good conductors of heat and electricity. They are malleable, they are ductile, they possess metallic luster and have tensile strength. Transition elements are hard except zinc, cadmium and mercury. They have high melting and boiling points. What is the reason? It is because of the involvement of the electrons from n-1 d orbital in addition to ns electrons. So in addition to ns electrons, n-1 d electrons will be involved in interatomic metallic bonding, as a result of which the bond will be quite strong and hence they have high melting and boiling points. Transition elements also have high enthalpies of atomization, and it reaches the maxima at the middle of the series. It is because when we reach the middle of the series, the configuration will be d5. So there will be one unpaired electron per d orbital, and as a result of which the interatomic interaction will be quite strong. Hence, transition elements are associated with high enthalpies of atomization.